What if I told you that some of the smartest physicists alive can't even agree whether the universe and reality needs explanation at all? Some of them say the universe just explains itself, and the others say, well, that is mathematically impossible. So the real question is, did the physics eliminate God, or did it accidentally bring us closer to it? So here is how we're going to approach it. Not with opinions, not with beliefs, but with physics. We're going to go through 4 main questions. First one is, why does the universe follow mathematical laws at all? Second, why are those laws perfectly tuned for life? Third, what actually happens at the quantum level? Fourth, where did everything come from in the first place? At each step, we'll look at what real physicists say, including where they completely disagree. And at the end, we'll see what physics can actually explain and what it simply can't. Physics doesn't just describe reality, it predicts it. Equations written on paper somehow match what actually happens in the universe. And not so-so. It's exactly what happens in the universe. There's a physicist named Eugen Wigner who called this the unreasonable effectiveness of mathematics. And what he meant is, there is no obvious reason this should work. Math is abstract. It exists in our heads, but the universe is physical, and yet somehow they line up perfectly. We can write an equation, and it tells us how planets will move, how particles behave, how the reality itself unfolds. So that creates the first real tension. Is math something we invented or something we discovered? Because if it's discovered, then the reality is structured in a way that exists independently of us. And that structure gets even stranger. Let's talk about something called fine-tuning. The universe runs on a few fundamental constants. Things like strength of gravity, electromagnetism, the nuclear forces, and if you change any of them just slightly, the whole system breaks. No atoms, no stars, no chemistry, basically no life. And there is a physicist, Roger Penrose, that we talked about in the previous video, who tried to actually calculate how unlikely our universe actually is. So his number was 1 in 10 to the power of 10 to the power of 123, which is an absurd number. It's like picking an atom out of observable universe. And it's basically saying this shouldn't happen randomly. This is where physicists start to disagree. Paul Davies looked at this and said, the impression of design is overwhelming. And what he means by that is not that it proves anything, but when you look at how precisely everything is balanced, it looks like it was set up intentionally. The pattern resembles design. But then you have someone like Steven Weinberg, and he basically takes the completely opposite position. He basically says the universe doesn't need a reason, it just exists. No deeper explanation required. So in his view, the universe is what you would call a brute fact. It's just there. No meaning behind it, no purpose behind it. So now we are not really arguing about physics anymore. We are arguing about something deeper, whether the reality itself needs explanation at all. But to avoid the idea of design, physicists came up with something else, the multiverse. And the idea is actually very simple. Instead of one universe, there are infinitely many. So even if most of them are chaotic and don't work, eventually one of them will randomly have the right conditions. And that one is ours. Yay! Physicists like Leonard Susskind support this idea, but then you have critics like George Ellis who say this isn't really science anymore, because science depends on observation, on testing, on being able to prove something wrong. And with the multiverse, you can't observe the universes, right? You can't test them, you can't falsify the data. So what you're doing is you're solving one mystery by introducing something you can never actually verify. So even Sean Carroll, who is open to these ideas, admits we might never be able to test it, which means we might never know if it's true. So the multiverse isn't a clean answer. It's a trade-off. Now, let's go deeper into quantum physics. So this is where things really start making intuitive sense. There's a famous experiment called the double-slit experiment. If you fire particles, like electrons, through two slits, they behave like waves. They create this interference pattern, as if they're going through both slits at the same time. But the moment you try to measure them, they suddenly behave like particles again, which is strange. As if they chose one path. So something about observation changes what's happening, and this is where interpretations come in. One of them, the Copenhagen interpretation, basically says, before you measure something, it doesn't exist in a definite state. It exists as a range of possibilities. So only when and once you measured it, does it become something concrete. Another interpretation called many worlds takes a completely different approach. It says nothing actually collapses. Every possible outcome happens, but in a separate branching universes. So every time something chooses, the universe splits. Then there is pilot wave theory, which says the particle always has a definite position, but it's being guided by some hidden structure, a wave we can't directly observe. So nothing is truly random. We just don't see what's controlling it. And the key point is this. These are not small differences. They completely change what the reality actually is. And physics doesn't know which one is correct. Now let's go to the biggest question, the beginning. The universe started with a Big Bang, but that creates a serious problem, because everything that begins needs a cause. But time itself began at the Big Bang. So what caused it, if there was no before? Stephen Hawking tried to solve this by saying, maybe the universe doesn't have a boundary in time at all. Maybe asking what came before is like asking what's north of the North Pole. And I mentioned it in one of the previous videos as well. It just doesn't make sense. But other physicists disagree. There's a theorem called the Born-Guth-Wilkin theorem, which suggests that any expanding universe must have a beginning. Alexander Wilkin, one of the physicists behind it, said, all the evidence we have points to the universe having a beginning. So now we're stuck with something strange, a beginning. That seems to require a cause, right? But causes require time. And time didn't exist yet. So physics gives us a starting point, but no clear explanation for why it happened. And even physicists admit the limits of what they're doing. Richard Feynman once said, we don't know why the laws of physics are what they are. We can describe them, we can use them, we can predict things with incredible precision, but we don't know why those laws exist in the first place. And that's the key thing. The deeper you go into physics, the more the why starts to disappear. You're left with descriptions, not explanations. So where does that leave us? Physics explains how the universe behaves, but it doesn't explain why there is a universe at all. It doesn't explain why the laws exist or why they're structured the way they are, or why anything exists instead of nothing. So, can physics explain God? Not really, but not because the idea is wrong, but because physics might not be built to answer that kind of question in the first place. And right now, we are standing exactly at the edge, where physics ends and something else begins. If you like these sort of videos, please subscribe to this channel. I'll be releasing them once or twice a week minimum. And until the next one, keep thinking.